Okay, so before I move on to encoding some other instructions, I just wanted to have a quick look at the way that I'm doing operand encoding right now. So if we look here, we can see that I've basically made some assumptions about how to use each operand. I assume that op1 is going to be rm and op2 is going to be reg, and then if operand 2, which is passed into emit, happens to be memory, then I switch them around. And this has worked for me so far because I've only been emitting simple instructions like syscall or ret, which take no operands, or I've been just emitting MOV, which happens to have, if we look at the operand encoding table here, it happens to have encodings where RM and reg can appear on either side. And so if I just pick one of them and then swap it around when I see mem in one of the places, this happens to work out for MOV with whatever NASM is choosing so that I can pass the tests. But this assumption is going to fall apart pretty quickly once I start encoding other instructions. So for example, if I start encoding, let's see, if I start encoding imul, let's say, so imul here expects, so other than this single operand case, which is always rm, the operand 1 and 2 and 3 cases always expect operand 1 to be a reg and operand 2 to be an rm. But if we take my logic into account here and we say that, okay, if we've got an imul with 2 register operands, then it means that I'm going to be assuming that this one is rm and this one is reg. And because neither of them are actually memory operands, it means they never get switched around, which means that I've picked the incorrect role for each operand for this instruction. So I could fix that for imul by just switching it around and just assuming the other order, or adding another case for trying to infer the roles of the operands from like the flags of the operands that were passed in. But that's quite a fragile way to do it, and it's just not going to work. So the way that we should actually be doing it is to make it part of the form. So the operand encoding here is obviously part of the form anyway, so it makes sense to just put it on the form struct. So if we go and look at MOV again, we can see some of the operand encodings here. So for example, M means RM, R means register, I means immediate, and O means that this is an opcode that's been, it's the register in the opcode. And then this one here, MI, means RM with an immediate. So we can just take these operand encodings that I actually care about, put them onto all of the forms, and then just switch on the new field to decide which operand plays which role in the encoding. I don't care about these two encodings here because I don't care about memory offsets right now. And then if we go and look at an instruction like ret, which is down here somewhere, this one has an operand encoding of ZO, which is where there are no operands. So I can basically just define all of these to put onto the form. So if we have a new field here called opn, this can also become a new type. And actually, it won't be a struct. We'll just make it a byte. And then we can do some consts. So it will make the 0 value invalid so that we can panic on it, which will force me to give all of the forms a correct operand encoding value. So this one will be unknown. Opn iota, and we'll just do opn all of the ones that we saw in MOV. So this will be MR, we've got RM, we've got OI, and we've got MI, and then the ret and syscall case was ZO. So then I just need to give all of these the correct operand encodings. So for example, if we do opn, this one is opn ZO. All of these MOV ones, I'll just fill in with opn MR for now. So these top ones are actually MR because there's a potential memory operand with a register. These ones here are the opposite, so this is register with a potential memory operand, so these should actually be RM. These ones here are all reg in opcode, which means these are all OI. And then these ones down here are a potential memory operand with an immediate, so these ones are MI. And because these forms actually imply certain things, so this one meaning that the reg is in the opcode, it means I can get rid of these flags, and I can get rid of the no ModRM flag, which means I can entirely remove this sort of hacky info byte that I've got at the moment. So we may as well actually do that now, if I just get rid of all of these info bytes. I can get rid of the has function here, because that's just using the info. Okay, and then we'll go to the encoder. So this is where we want to say, for example, var.reg rm operand, and then we would switch on the form op-encoding. So in the default case, we would panic to say it's an unsupported op-n. We'll get rid of this. And then I got rid of the has helper here. So for example, we'll say reg in opcode is if the form is equal to, if the operand encoding is equal to op-n-oi. And then this has ModRM could actually become a helper function on the op-n. So that makes this read a bit better as well. So we'll actually go back to here and add a helper function. So we got op-n has ModRM. So we'll just switch on itself. And in the case where this is the register in opcode case, or it's the no operand case, then we'll return false, otherwise we'll just return true. Oh. Okay, and we'll get rid of these consts up here for the flags that I don't need anymore. So if we run this, if I haven't forgotten anything, this should panic. Okay, yep, so panics on unsupported op-n, so now I just need to implement these cases. So in the case where it is op-n zo, just to stop it panicking, we just want to do nothing here. In the case where it's op-n-mr, this is where rm would come first, and then it would be register, so this will be op1 and op2. In the case where it's rm, this is the exact opposite, so this is reg rm equals op1 and op2. And then op-n-oi is the same as this, so we're using rm in the case of reg in opcode. And in the case of op-n-mi, this m also means that it's the rm coming first, so that this would be the operand one is rm as well. So I think that's all 5 of the operand encodings that I actually have. So if I run this test, okay, we get some incorrect values here. So this is probably because I haven't updated the encodings here. So these two here are supposed to be rm. These ones here I said were OI, and these ones here I said were MI. So now if we run the tests, now it passes. So this was just a quick change, but I thought it sort of warranted its own video because it's worth explaining as its own thing before I move on to encoding other instructions.